What's going on, ladies and gentlemen? So today we're going to be doing data wrangling in R. So what we're going to do is we're going to calculate one number from a huge data set. It's going to have about 10,000 rows and 13 columns. So just to kind of clear things up, when I say data wrangling, and whenever you hear that, don't get kind of intimidated by the word, because it sounds a little strange, or kind of separated from reality. What data wrangling really is just transforming or mapping data in a variety of different ways to extract meaning, or make the data set you're working with, the raw data, a little more valuable. It can be used for things like analytics, visualization, and so forth. It's a very important part of data science and application development, and it's all around us. So excited to get into it, and let's dive right in. So I have RStudio open. What we're going to do is we're going to hit File, New File, and we're going to open up our notebook. By the way, if you're not 100% sure what RStudio is, or how to install R, I'll kind of drop down some instructions in the comments below. If you get stuck or anything, just leave a comment down below and let me know. Shoot me a message and I'll be glad to help out. So what we're going to first do is we're going to load up some libraries. So we're going to need the tidyverse library. I'm just going to hit tab on that, and we're going to pull in quandl as well, with a capital Q. And by the way, if you don't have these libraries, what you can do is this function called install packages, and in quotes you just put in the package itself, so tidyverse, and then you would just kind of select this and run it. I'm not going to do that because I already have them. So what's great about these R notebooks is they come in chunks. So you can see there's like a little play button over here. If I hit play right now, it's going to load these libraries. I didn't really have to select anything, or highlight the code and hit Control Enter. It's just a little more easy. If you want to add new chunks, the command on Windows is Control Alt I. I'm not entirely sure what that command is on iOS on a Mac, so if you do, be appreciative if you could leave it down below in the comments for people following along on their Macs. So let's pull in some Apple stock price data here, data from the quandl. So the command in quandl is literally just quandl. The way their downloads work is you start off with their database name followed by a series name or ticker. Throughout the course of these series that I'll be doing on YouTube, I'll introduce you to a lot of different packages, so that way you get exposure to a lot of different data services providers, different packages for statistical analysis, machine learning regressions, and classifications, and shiny applications, and everything in between. So looking forward to that. Let's just give this a quick run. I just hit Control Enter after selecting everything. You can see I'm contacting the interwebs now, and it's kind of pulled in down here below. That's another great thing about these R notebooks, is you put your input over here and your output just kind of spits out right below. So you can see we have all this data. So where do we want to get to now from this data? So what I want to do today that will really let us flex our data wrangling muscle is to calculate the volume weighted average price for Apple. For Apple, starting from, let's say, 2015 to now. All right. So just to kind of clarify what I mean when I say volume weighted average price. So you have these stock prices. They have like an open, high, low, close. You also have adjusted high, low, close. We also have volume. So really, the volume weighted average price is exactly what it sounds like. We'll just take the adjusted close and the adjusted volume, which I assume is there because of maybe some reporting errors on exchanges or something, but I expect it would pretty much be the same thing as the volume column. Just for consistency, let's use the adjusted close and adjusted volume there. So first step to get to this one number out of these 9,381 rows and 13 columns is we're going to create an object called AAPL, and we're just going to copy and paste this little command over here, and once we run that, we'll now have a data frame called AAPL. You can see here in the global environment on the top right, we have basically what we were just looking at under this AAPL variable. So if I just run AAPL, you can see it's the same exact thing. So just to, I mean, I'll get into visualization and so forth in our next series. We're going to take a really deep dive into ggplot and some interactive charting libraries. But first, I just want to take a quick peek at this data. So what I can do is just create a quick plot using ggplot. By the way, the GG and ggplot stands for the grammar of graphics. So it's a nice little tidbit, I guess. So if I just do AES, and our date, AES stands for aesthetics, and Y will do just close for now. We're not going to use that for our analysis, but I just want to get a quick idea of what this looks like. And whoa, you can see this is a closing price. So actually what happened here is there's a stock split. So this is kind of misleading. Apple's stock price didn't actually drop from 600 to looks like 100 or so, or slightly below 100 at the time of the split, but it just kind of happened because they just kind of diluted their shares to, for whatever reason. So this is just a quick peek at the data, and I want to start at 2015, which, interestingly is after the split. You could maybe even consider a stock split a bit of a regime change, although there's nothing really fundamentally different about the company after a stock split. But just to kind of, like I said, flex our data wrangling muscle, we'll start in 2015 to now. So let's just comment all this out, and I do need to explain something here before we proceed. You can see this little funny looking 3-character symbol. This is called a pipe operator, and it's pretty much the best way to think of a pipe operator is as a word then. So anything to the left of the pipe operator is your starting point, right? And you want to do something after. In this instance, I just did a quick line chart, but you can stack these pipe operators on top of each other, so it can become pretty powerful. So you start off with something and then you do something else. So what I did in this instance was I started with this data set and then I visualized it. So that's basically what the pipe operator is, and it'll make a little more intuitive sense once we get into these data wrangling functions. So the first function I want to introduce you to is the select function. So select columns. So basically, I mean, I want to get to the volume weighted average price for Apple starting in 2015 to now. I have way too many columns. I don't need all these columns, so I'm just going to, collapse a view of this data frame into the columns that I need. So what do I need? I need the date. We're not going to use the unadjusted closing price. I'm going to use the adjusted closing price. And by the way, if you're used to R at all, if you've used R in the past, you'll know that having spaces in your column names can be a little problematic. That's pretty much why I'm putting these in quotes, and that's also the reason why date is not in quotes. You'll see when I run this, it's going to run just fine, but I can show you what it'll look like if I run it without quotes in a second. So there you go. So you can see I just wrote the wrong word there. So there we go. So I have date, adjusted close, and adjusted volume. So basically I've selected 3 columns out of this main data frame. You can see on the right on my global environment, we have all of the initial column names, but I've just kind of condensed that into these 3 things. So that's select. It just kind of pulls in the columns that you want. And just because I said I would, I'll show you what it looks like if I ran this without the quotes. It just says there's a unexpected symbol. It doesn't like the fact that I have these you know, columns that have spaces without quotes in them. So that's basically the select statement. And because working with columns with spaces can be problematic, let's go ahead and rename these two. So that's kind of the second data wrangling function I'll introduce you to. It's called rename. So the way rename works is, let's say I want to rename this to close. So I want a new column called close to be equal to adjusted close, adj dot close, and when I run that, you can see this new column name is now close. And don't forget to add in this pipe operator. And just to explain once again what the kind of function is here is you're taking everything to the left hand side and you're piping things through. You're starting here and then you're doing something else. So I have Apple, then I'm selecting these columns, and then I'm renaming one of the columns. So because we have another problematic column, you can do the same thing we did in the select statement by comma delimiting these different arguments here. Volume, and you can see we have nice kind of cleaned up column names. So just rename column. So that's basically what rename does. So that's cool, and I at this point really would like to see what the chart looks like with the adjusted closing price, because that's a data I'm really interested in. That's the data I'm going to be working with to calculate the volume weighted average price. So let's just give this a quick run and see what it looks like now. So you can see it's, if you remember from the chart before, it went all the way up to 600-700. But because this has been adjusted for stock splits and dividends and so forth, it's a little more continuous. It's less dramatic. So that's the data we really want to be working with. So let's just kind of get rid of this. I just wanted to show you that. We'll get back into the data wrangling. So we've so far just kind of started off with this data frame. We've selected the columns we want, and we've renamed those columns. Now I'm going to start over here at 2015 and just look at that data specifically. So there's going to be a new function. It's called filter. And the best way to think about filter is it's like the row equivalent of select. So select is to columns and filter is to rows. So let's say I want my date to be greater than or equal to 2015, first of the year and the first day of the month. So it's just a year, month, date over here. If I give that a quick run, you'll see I have a lot less rows now. I have 793 rows. And in fact, I can go all the way to the end of this data set, just looking here in my R notebook. You can see, in fact, it starts 2015 0102. You may be wondering why, when I said greater than or equals to the 1st of January, the very first observation is the 2nd of January. It's pretty much just because there wasn't any trading activity on the 1st of the year. Markets were closed, people were still celebrating the New Year's, and that's why we don't have any data for the 1st of January. So subset your rows. So I don't know if that's clear enough, but basically it's just a way to collapse either categorical variables or numeric variables such as dates. You can say I want my closing price to be greater than or equal to 100, just to see only stock prices when the stock was greater than or equal to 100. But for this instance, we want every single observation. And you may be wondering what's the actual value of calculating the volume weighted average price. I mean, it could be used for a variety of different purposes. Some hedge funds, for example, could use it to impute like a algorithmic trading strategy in terms of when they want to enter or exit a position, or it could be used in mutual funds and insurance companies. The use is pretty broad in scope. But the beauty of doing what we're doing is it allows us to kind of touch a bunch of different data wrangling techniques to get to this one number. So I just want to kind of illustrate something really quickly. If I do summary, summary is like a base R command. It basically just gives like some summary statistics on your different columns for your data frame. So remember, I use a pipe operator, so I piped everything through, and then I decided to run this summary really quick. So you can see the start date. The minimum is 2015 because that's what my filter is. The max is February 2018. Minimum price is $88.29. The maximum is $179.26, and the mean is $124.74. So I'm going to be pretty interested to see what the difference is between just the unweighted mean versus the volume weighted average. So I'm just going to comment that out and just write summary statistics just in case you want to pause the video and follow along. I have some comments over there. Just add another comment over here so you can delete that one and still have the other one there. Alright, so now we're going to be working. Let's just kind of look at where we are right now. So here's where we are. By the way, I'm running this code just by selecting the specific section that I want to run, and then I hit Control Enter. So mutate is the next one, not mutate. It's going to be mutate. Alright, so what we have here is mutate. So modify existing columns or create new ones. So that's pretty much what mutate does. It allows you to modify existing columns or create new ones. So with this, we're gonna do both actually. We're first gonna modify the volume column just to get like a share of the daily volume relative to the total volume, and then we're gonna create a couple new columns to eventually be able to calculate our volume weighted average price. So we're going to mutate. Kind of added that pipe operator a little early. I'm going to get rid of that for now. So I'm going to say volume. I want my volume column to now be equals to volume divided by the sum of all volume. So if I run that, we're just going to get a bunch of ratios. So these are just that day's volume represented as a share of the total volume across all 793 rows. It's as simple as that. So the next mutate we're going to do is we're going to create a new column. So we're going to say share. Let's do like a volume. Let's do close. Whoa. Let's do a close share over here equals close times volume. So just before I run this, you can see I have three columns. One's called close, one's called volume. What we would expect is there to now be a new column called close share, which, as you can see here, is just close times volume. So I'm going to give that a quick run, and indeed that's the case. So in this instance, we created a new column, and in this instance, we modified an existing column. So yeah, mutate's pretty powerful, and the kind of next step we need to get to is, we're almost there. We're almost done calculating our volume weighted average share price. All we need to do is just take This, like, close price multiplied by the share of volume relative to total volume, and just kind of add everything up. So we do that by using this command called summarize. Summarize. You can use, what's interesting is you can spell summarize with an S or a Z. You can see here. It doesn't really matter. It will do the same thing. So whatever floats your boat. So what summarize does is it basically collapses and summarizes the data. So it just allows you to summarize the data as the name would imply. So let's just create a column name called VWAP, which is volume weighted average price. And I should say, I mean, if it's I don't know how common it is to look at the volume weighted average price on a daily basis. It does come into use with, like I was saying, algorithmic trading strategies where you're looking at intraday, daily, or tick data, where instead of just a date, we have a date time. So I'll get into that in future sessions. Maybe we can develop a trading strategy of our own. Just let me know what you might be interested in. We can, take it from there. Sure. The next kind of episode is going to be visualizing our data. So it's really an important part of, data exploration, extrapolating some meaning out of your information. So what we have here, I think the summary statistics before told us 124. You can see we have 120, so we're about $4 below the just unweighted average price. So just to kind of wrap things up, because I don't like looking at money and anything less than hundredths, I'm gonna round that to the hundredth, and then just rerun this. So you can see it's 120.57. So just to kind of summarize what we did here, and we can even just kind of create a variable called VWAP, and then just rerun all of this over here. We first started off with our Apple data set where we had all of these different columns that we didn't need and more rows than we needed. We selected the columns that we wanted to work with and those columns only. We kind of renamed some of the problematic columns, the ones with spaces that are kind of tricky to work with in R, that we could later, having renamed them, use them for a variety of different purposes. We kind of filtered our date column to only reflect dates that were greater than or equal to 2015. Then we mutated our volume column. We kind of changed it to just represent a share relative to the total volume for that window, that date window that we had specified before. And then we calculated the close share, which is just the closing price times that share of volume that we calculated before. And then we finally, just calculated the VWAP, the volume weighted average price, which we have here at $120.57. So there you have it. I mean, data wrangling, it isn't the most exciting part of data science, but it's probably the most necessary. It is the mechanism at which you extract meaning out of your information. It's the mechanism at which you create features to pass through complicated, deep learning algorithms. It's the mechanism at which you can create really cool visualizations. It's pretty broad in scope, and it affects us on a daily basis. If you are used to working with Excel in your professional life, chances are you've done data wrangling of some sort. So the beauty of doing it in R is it will allow you to automate certain tasks that you can just go ahead and just click on this play button or create a script to run some sort of daily routine to wrangle data if you need data being updated on a persistent basis. Ours is a great way to automate that instead of having to jump into an Excel file and doing it manually. I say if it can be automated, it should be automated. So that just makes you more productive and it allows you to take your work to the next level. So this is going to set a really great foundation for us to visualize our data, which we'll touch kind of next episode. I'll be introducing you to ggplot, which is a really powerful library. We kind of got our beaks a little wet just looking at a line chart, but I'll be introducing you to some interactive visualizations in R kind of next episode. I'll teach you, how to really make your charts pop with colors and different, different tips and tricks that will just make your charts a lot more powerful to convey or tell a story. So there you have it. If you have any questions, feel free to, leave a comment down below. I'd appreciate a like or subscribe if you are interested in following along. And if you want to see anything in the future, just definitely let me know. I'll be glad to create an episode on it. So take it easy and have a great day. Alright, so just a quick recap of what we went through. So we did some data wrangling in R to calculate the volume weighted average share price for Apple stock. Here are the functions that we went through. So some of the functions we did were select, where we pulled in whichever column we kind of specified. So you just define the column and pull in that column. You can also use a negative symbol in front of the column name to remove the column itself. We also use rename, so you just kind of define whatever you want a new column name to be, and that's what rename does. It can be used to kind of clean up column names that aren't very user-friendly, or just to get the column names a little more consistent. So filter, similar to select, but it takes your parameters and filters a row. So let's say I want my date to start at 2015. You would just do greater than or equal to 2015. Same thing works with categorical variables. So let's say you have I don't know, like a month of the year. You can say where the month of the year is, just filter your data down to where the month of the year is December only. So if you want to look at maybe shopping trends for clothes or something, you can. It's very seasonal, so you would look at specific months. So we also did mutate. So mutate allows you to modify existing columns or create new ones. And finally, we use summarize, which allows you to summarize or aggregate the data. One kind of special shout out is this pipe operator, which basically just is equal to the word then. So the pipe operator takes left-hand side and then does something else on right-hand side. So it's pretty much the universe of what we went through in this video. If you have any more questions, just drop them down below in the comments. I'll be happy to answer or troubleshoot with you. If you get any error messages, don't be discouraged. It's very common. I write code pretty much every day and I still get error messages. It's just kind of, it comes with the territory. So if there are any future courses you'd like to see, just give me a shout. I'm happy to work them in. I kind of spoke to those in the video a bit, but I'd like to, kind of build a good foundation where you can wrangle the data and visualize the data before we get into some more of the complicated stuff like creating trading strategies or developing machine learning algorithms or doing deep learning classifications and things of that nature. And if you like the video, please I do appreciate it if you like and share. Subscribe to my channel for future videos, and looking forward to the next one. So take it easy and have a great day.